Thanks for that.
Yeah, it just occurred to me.
So I'll just click the record. I'll share my screen so we can see the actual gizmo. Okay, so a couple other things I have to get up here too is the participants in the chat, just so I can see stuff. So, Gizmo itself is probably what you're used to at this point. It's questions with boxes to write in. The first couple here are just having you look at the first two. Sorry, I just want to get this open on the same screen so I don't have to go back and forth. Oops. Okay, so first two, you're just looking at the chimpanzee and Homo sapiens humans. So you can toggle back and forth between those. This is some of the big words that you have, like in the tables, they have all the fancy Latin names for these fossils. I think all of them except for the chimpanzee and the modern human are no longer around. They're extinct. They've only found fossil evidence of them. So you've got general stuff like looking at the front, the side, which I don't think you need to do any measurements on the side from what oh yeah, you do. You gotta do some kind of nose, mouth angles. And then there's today's stuff, you're gonna have to look at the bottom a lot to do that. So the first stuff though, they're just kind of asking you to make general descriptions of which skull is whose, which shouldn't be too difficult. What features, so what things what helped you know that it was a human skull or a chimpanzee skull? Me just looking at the pictures that are here, there's definitely something that stands out that lets you know it's a chimpanzee versus a human. And then the next couple questions in this Gizmo warm-up, they have some terms here. So some of these are anatomy terms. Some of them are more evolution terms or classification of things, meaning who belongs to what group. So we've got the Foramen Magnum, which in anatomy is the giant hole. Foramen means hole in a bone, and magnum in this means large. So we've got the large hole in the bottom of the skull. This is the Foramen Magnum. It's right on both sides here. There's these little nubbins that attach to your vertebrae. So they hold the skull to the vertebrae, your neck, and they also let the spinal cord go through, which is why the hole's there in general. So that's just what that hole is. If you forget that, I think it's labeled in the Gizmo, or you can Google what is a Foramen Magnum, and it should pop up with something. And then where that Foramen Magnum is lets you know or gives you a clue into if that creature is bipedal, which means if you think bicycle means two. A podiatrist or a pedal kind of has to do with feet. So 2 feet, if they walk on 2 legs, they're bipedal. Versus, I don't know if the actual term is quadrupedal or tetrapod, thinking more walking on 4 legs instead of standing upright on 2. So those are some of those terms there. And then we have hominid and hominin. The literal difference there is this D changes into an N. So hominid kind of means a group of animals that are ape-like, probably would be the best thing because it does include chimpanzees. So a gorilla would be in a hominid group. Any of the stuff you're going to look at today on the Gizmo will be a hominid. So the difference between the one with the D and the one with an N, the hominin, is a hominin is one that kind of was along the path of human evolution. So a chimpanzee isn't a hominin because it's on its own path. It became a chimpanzee, not necessarily a human. So that's the difference there. I think a couple pages down they use hominin and they ask you like, which one of the things that you looked at do you think is a hominin? Meaning it kind of was humans' direct ancestor of sorts. Okay. So we're doing front view comparisons, then we do bottom view comparisons. You're just making visual comparisons or differences. So you don't necessarily need to do any measurements. You're just looking at them and coming up with a couple differences or similarities. So where we get to the measurements here, and it's really about the Foramen Magnum. And it says even skulls of the same species can have some differences in shape and size. But we kind of use these comparison values, which are called indexes. The calculation actually is very similar to a percent. So it's not a difficult ratio or calculation to do. But if you compare two measurements and you do a calculation with them, you're gonna just kind of call that an index. So cranium hopefully isn't the weirdest word on here. Cranium is just a skull. So where we do get some really big words here, and if you want to, you can go to this sheet and we can change some of these things, but you see they're all labeled right here. So they have this opistheon index, which the opistheon is just the base of the foramen magnum. Then they have opistocranium and the oral, and that's the measurements you're going to be making. So they have some of these things right here where they use these big words, and they do have, that's what they're called, but maybe a better way to write them in so you don't have to keep looking things up is back to, for lack of a better word, back to the hole in the skull. And then this measurement, the opistocranium, can you, and it's going to be my class. So this one is the front, the back of the skull to the front is what you're measuring. And then you're taking your first measurement, so this one here, dividing it by your second measurement, and you're multiplying by 100. So that's why I said it kind of seems like a percentage, because you're taking the part, the shorter distance, divided by the longer distance, which is kind of a percent, sort of. Okay. For Peyton, I'm gonna have to look up my class code, so I wonder if it's easy to do just right here. Been a very long time since I've looked up my class code. Right there. So MH9 GKC. Can I copy that? There we go. So, oops. So let's do one of these measurements. It walks you through it right here. It uses the big words, but really you're going from the back of the skull to the beginning of the foramen magnum. So how we do that, okay, so I've got the chimpanzee up right now. I go to the bottom view and I use the ruler, and then you click and drag it on the sheet. It looks like you want to have the place you want to measure in the middle of the circle, and then you bring that to roughly the middle and it tells you the measurement right down here. So if you've got it open or you got a piece of paper where you can write some stuff down, we just did the first measurement. So 2.25 centimeters. And that was for the pan troglodytes, aka the chimpanzee. Okay. And then we do the other measurement. So we drag them to the back of the skull to the front of the skull and get that measurement. Okay. So that says 20.07. Centimeters. Okay. So then we do the measurement, or the calculation, I should say. Got 2.25 divided by 20.07. And that gives us a 0.11, but it does say to multiply by 100. So it kind of looks like a percentage. So 11.21 is fine. I don't really think it's a percentage necessarily, so we might just leave it unitless at this point. Because dividing units by each other kind of get rid of them. So that's the first measurement there, the whole thing. You'd obviously do that for humans, Homo sapiens. And then it kind of goes into the analyzing stuff here. So it says this index, this Opisthion index, which is this number over here, is an indicator, or it tells us where the foramen magnum is situated or located. Okay, so the greater the index, the closer the foramen magnum is to the center of the cranium. So if we just take a look right here, to me, this doesn't look like the foramen magnum is in the center of the skull. It's more towards the back. So that would be why I got a number that's smaller. So if the human skull has, obviously looks like the foramen magnum is a little bit more towards the center. So I would probably expect my number to be, according to what they just said there, it would be a higher number. So a low value for the index occurs when the foramen magnum is situated in the rear of the cranium. Okay, this may indicate that the species walks on its knuckles or four legs. And if it's towards the center, that indicates the species stands upright. Okay, so probably not too hard to know that humans, for the majority of their time, walk around on two legs. Chimpanzee, while they can walk on two legs, they don't all the time. So they use their knuckles as they suggest here. So why that's important for us, and it probably is pretty easy to know that just from the humans and the chimpanzees. But why that's important to know is when you get to some of these fossil ones. So you're going to do the same thing that we just did for the humans and the chimpanzees, for the Afarensis, Africanus, the P. boisei, Homo habilis, Homo erectus, all these different ones. We've got Neanderthalis, or Neanderthals, and Homo florensis. So you're going to do all those measurements for those different skulls. So all you got to do is, you're just looking into a different skull and doing those same two measurements from the back to the foramen magnum and from the back to the front. And then you're going to use some of that information, those indexes, to figure out which ones do you think are hominins. So that's where that word comes in, and they defined it up here too. Hominids that belong to the lineage that led to humans. So you're just going to try to figure out which ones do you think are essentially more closely related to humans than a chimpanzee is. Right. And then based on the Opisthion index, so that number that we calculated here, which one is most similar to the human skull? So which ones belong to the lineage that led to humans, and which ones do you think are the most similar to us out of those options, just based on this one number here that you calculated, like this 11.21. Okay. Which means you're probably going to compare it to the human value, whatever you get here. You're going to kind of make comparisons with that. Okay, and then you're just explaining why would something that walks on two legs have their foramen magnum in the middle of their skull versus something that walks on four be towards the back. You're just trying to come up with an idea for that. Okay, and that brings us to activity C. So this is a different measurement. You're going to be counting teeth on some of these. So you're just literally counting the teeth that you see. And then we're going to be measuring the angle of kind of the what do they call this, zygomatic process, which is your cheekbone up in front and going out to the tip of your maxilla, which is the fancy name for your upper jaw. Right, so we've got some of those things labeled right here. You've got your cheekbone that we can see. And we have our maxilla, which is our upper jaw or upper mandible. So we're going to be taking some of those measurements. So it kind of walks you through that. So we have one of them at the opening of the orbit, which is the fancy name for your eye socket. We have one of them on the upper part, it looks like, of the maxilla, and one kind of right above the teeth on the the zygomatic process is here, and the maxilla is there. So we have all those different species again. So the first one is the chimpanzee. So let's do the chimpanzee, and we have to have the side view for this measurement, and we don't need the ruler anymore. I don't know why there's two different ones. There's apparently two of them, but we only need one. So we go to right below the eye orbit, right to the top of the zygomatic process, your cheekbone, and you bring the other one right above the teeth. And it tells you an angle. So 142.66, and we can go plug that in right there. Oops. You can write degrees, or the other way, if you ever have to do it in the future, is a capital O. If you make that a superscript, it looks like a degree symbol. So that's how I get away with it when I really need to do it. Okay. And then there's a couple that have lines in them, so you don't have to worry about them. I think that's because if we look at them, what were some of them? Neanderthal, I don't know. Some of the skulls aren't really complete. Like the Neanderthal, it's a mangled little fossil. There's really not much going on there, so you can't really do an angle. So that's why some of them aren't there. So then you have all of your angles. Select the bottom view, so you can look at the size and shape of each species palate. So palate is just the top of your mouth. So if you touch the top of your mouth with your tongue, that's your palate. So if we look at chimp and look at the bottom, you're just going to be comparing the size and shape of the roof of the mouth, the palate, on some of these different species. And that's just a visual comparison, I do believe. Go away. Okay. how does the palate shape relate to the angle of that you just measured up here? So there's probably some comparison there. And then you count teeth. So you count teeth on chimps, on humans, and that's all. So how does the size and shape of human canines compare to chimp canines? Okay. So then you're going to try to come up with an idea for why there is such a big difference between chimps and humans when we eat similar foods. So kind of got to think about, what does the size of a jaw have to do with anything? Like, why would you want to have a bigger jaw? Why would a smaller jaw be okay for certain things? And think about the muscles that go along with the size of a jaw. And then what is the relationship between evolution of bipedalism? The increase in cranial capacity. Okay. Cranial capacity, this might have been actually one of the activities we skipped because we went right from A to C.
Mm-hmm.
But it's not too difficult here to just know what cranial capacity is. So relative size of the cranial capacity is really referring to how much space does the brain have. So if we look at chimpanzee skull compared to human, we notice that the cranial capacity is much larger on the human than it is on the chimp, at least kind of relative size. It's like we swapped the size of our jaw for the size of our cranium. So that's all that's referring to. Decrease in tooth and mouth size of hominins. Okay, so you're just kind of putting together a general idea of kind of how us becoming bipedal, how us getting bigger cranium size, how us having a smaller tooth size. So what is that relationship? Did it get bigger over time? Did they get smaller over time? That's really what the relationship is asking. Okay. I think that, oh, wow, there's more. Age. Oh, age. So age is gotten from this show information here. So if you go to one that's actually a fossil, it tells you like how many years ago they aged this fossil to. So that's all that's referring to. As you go, you have to click on that information part and you write in how old these fossils were. The age for the stuff that is still alive would, to me, be 0, would be fine. But anything that's a fossil, you're going to have an actual fossil date. And then that kind of gives you a timeline. So obviously, some of the older fossils you would expect to be the most different from either the chimp or the human. And some of the newer fossils you'd expect to be more similar, potentially, to human or chimpanzee, depending on their lineage. So that's what summarize how hominins changed as they evolved, is maybe look at the oldest fossil and some of its measurements that you did up above, like the angle and that fancy index, the opicion or whatever that was, and just say, well, it started out like this, and then over time that index started to get bigger, smaller, or the angle started to get bigger, smaller, that kind of thing. Okay, so it literally tells you Homo floresiensis is the youngest. So in what ways does this species not follow the pattern of human evolution that you just described? So there must be something goofy that's going on with Homo floresiensis. And you just got to kind of describe how it's different than what you just said right up here. It must break that pattern. Okay. So otherwise, this is broken apart into part A and C. C starts where you're doing the angles, so this stuff is part C. You can work on part C on Monday if you don't want to get to it today. Ultimately, I guess not too concerned when you work on stuff as long as it's done by, 11:59 on Monday?
Yep.
Okay. Now, are there any pressing questions or anything? Okay. If not, you could head out, or you could start working on this and let us know if you have questions. That's an option for you too. We can always just have the Zoom meeting going. I'll stop the recording, but this is